I let's start 3.2. 3.2 polynomial functions. So eventually it'll get harder, but this question is going to keep coming up. Find the zeros of the quadratic function. Basically, that means when this function touches the x-axis. And we've been doing that all along. So just set this function equal to 0, right? Solve for x. I'll write this on the paper right now. Find all zeros of y equal to x squared plus 2x minus 24. So let's switch over. So again, we've done this before. I just want you to remember, right? The zeros mean your function is touching the x-axis, which also means that you have no y value, right? The y value is 0. So it's not necessarily that I'm setting it to 0. It just means that I'm on the axis, which means y has to be 0. So then you factor it. Let's see, factors of negative 24 that add up to 2. That'll be plus 6 minus 4 equal to 0, right? Let me see if I can make that look a little prettier. Maybe it's my crappy pen. And then zero product property says you set it equal to 0. And you have your two zeros. So now let's open up Desmos. Wait, that is my Desmos. Okay. Again, this is just a simple beginning example. Eventually, you're going to do like higher powered functions, but we want to start with something simple, right? It's the axis. Oh, here it is. So these are, when they say zeros, they want these values. So we found it on paper. X equals negative 6, x equals 4, right? The two values when y is 0. So that concept is going to be important once we start doing any function, not just quadratics. Just wanted to make sure that you know that. So here's stuff we did on paper already, and then solve for the zeros. Let's move on to polynomials. So in the notes that are in the canvas, they have explanations to what is defined as a polynomial. So here's the definition. So this is in the notes um, for what is a polynomial. So basically, it can be written as terms with coefficients and variables with n to n minus 1 uh, powers, but those powers have to be whole numbers. So, for example, let's see, the x squared is a whole number, the 2, the degrees, two, or not the degree, but the power on the x is 2. Here it's a 1, but over here we have a 1 half, right? Because square root is a half power, so it's not a polynomial because this term has a square root part. These two terms are fine. This term is not a whole number because it's when you make it into a when you bring up the x to the 6 to the top and it becomes negative, right? Using the property. We said it has to be a whole number, so we mean positive numbers. Right? We said, yeah, defined as a whole number. So that's negative integer. So no. Over here though, The powers are 9 and 5, so yeah, we're fine. No big deal. This is a constant function, it's just a number. All constants are polynomials. So to answer the question, A, no, because the square root is a fractional power. B, no, because x to the negative 6 is a negative power, or 1 over x to the 6 is not a polynomial. C and D are polynomials because 9 and 5 are fine, and negative 7 is a constant. So it fits this definition. So the easy way to understand is it looks like, in a different language to you. The powers need to be positive and whole. As long as that's the case, then you're good. A and B were not was the A was not a whole number, B was not positive, so there you go. Let's move on. So yeah, please read the uh, definition of polynomial. On this guy, they want us to find the zeros, so it's already factored. So we should have a few zeros. So let's go ahead and solve this on paper. So number two, write this down and shift over. Okay, so it's number two. Well, in the homework, it's number, let's see, actually, three. Okay. So here's an example of higher degree polynomials. So you can't really, since it's factor, we don't have to worry about using special techniques. We can just use zero factor property. So basically, set this to zero, right? Which gives us these equations. Right, just solve for x. Divide by 5 both sides, plus 7 both sides, gets me to here, there. This guy, I can either factor this or square root both sides. So I move the 36 over, then I'm going to square root. It forces me to add the plus or minus 6. So we have 1, 2, 3, 4 different zeros. So the zeros of this polynomial is 0, 6, negative 6, and 7. So let's look at a graph one more time so you can see what that looks like. Righty, so there's the functions. That looks weird. Let me fix the x-axis here. Negative 10 and there's my zeros. 4 zeros that I found. Now, if you want to see the y better, I guess we could go something like that. It's kind of cool. There we go. That's pretty. Like 4 zeros. Anyway, so on paper we set it to 0 and factored. Well, it was already factored. We just solved. But that's what we solve for, and that's what they mean by find the zeros. Okay. Now let's move on to something else. All right. So here they're asking about finding the zeros and then talking about its multiplicity. And it's pretty straightforward. Check it out. Only thing you got to worry about is what is the power on each factor. These are ones because there's nothing there, right? So when you solve for these zeros, these factors will all have a zero. Once you've done that, then you'll say, okay, well, this one has a one. That's a multiplicity one, multiplicity one, multiplicity two. That's pretty much it. So look at the answer, right? So if you solve for x on all of them, I guess I'll show you on paper and that might be more clear. Okay, let me write this down. Okay, so basically, let's go ahead and set each one to zero, right? Or you're going to set the entire thing the proper way, right? Set this entire thing to zero, which then gives you each of these factors. I'm going to run it this way just so, that's fine. Next more space. Okay, so divide both sides by 7, right? You get 0. So this one right here has multiplicity 1 because this has a power of 1. That's it. This guy, same thing. Solve for x, right? Multiplicity 1. This has a 2 on it. So when you solve for x, right, square root both sides, you get to here, you get to there. Since the original had a 2, this 0, that's multiplicity 2. This guy, multiplicity 1. How many goodness, yeah. Sorry, I got distracted. Um, anyway, I forgot where I left off. I was reading y'all's remind messages. Okay. Yeah, so these powers here basically tell you multiplicity. That's all you got to remember. So solve everything like normal and just label which zeros have multiplicity. One, two, or whatever. So x equals, just to make it simple and more clear, 0, -8, 9, multiplicity 1, x equals 12, multiplicity 2. There we go. Let's go to another question. No, already. So here we go. End behavior. All that means is what's happening at the end, literally. It's like, okay, well, it's going downward at the left side and it's going downward at the right side. So when I'm approaching negative infinity in this direction, the graph's going down. When I approach the x in the positive infinity direction, graph is still going down. So the end behavior for this guy would be bottom on the left and right. So the way they phrase it, let me get back to the notes or the homework example. The notes has more details. Here we go. So when does it fall on the left? Does it rise on the right? So this is what you got to know. If the degree is odd, n, so the highest power, then it's going to do this. Left, down on the left, up on the right, down the left, up on the right. If it is odd but negative, then this flips over. So then it's going up on the left, down on the right. Okay. So just look at the degree. All you got to do. Now, if it's even and the number in front of the coefficient of the highest power is positive, then they both open down. If it's negative, they both open. Sorry. If it's positive, it opens up. If it's negative, it opens down. So look at this guy. Highest power is 3. So that's odd. It's the number in front is a positive 2, so that's positive. So it's going to be case 1, right? N is odd. That's the degree. This is the coefficient greater than 0, meaning positive. So falls on the left, goes up on the right. Riles on the left. Yeah, so that would be A, case 1. B, even and negative. So that means they're both going to be pointing down. There's -4 and even degree. So it's going to be graph falls on the left and falls to the right. Yeah, so D, A. That's pretty much it. Just look at the degree. Now, if it's not written as terms, this one's factored. You have to either multiply it out or kind of try to figure it out. So since this is positive, this is a 2, this is a 2 and a 1, so I know the degree is going to be 3, the highest, just because I'm adding them up. So this times that, it's going to be 3. So it's going to be odd. Now, is it going to be negative though? That will depend on this guy and this guy. So when I multiply them out, I get a negative. So it has to be so negative and odd, case 2, which is, yeah, what they say here. But if you can't see it, then I suggest just multiply it all out. That's what they did. Like, check it out. Their shortcut was, well, the leading term, if you were just to square this part and then multiply by this, then you'll have an idea what the big term's going to be. That's another way to do it, is just take this term, square it, or do whatever this power is to it, and then multiply it by that. And then just follow the rules. Is it case one, two, three, four? So I'd say write these down on your notes or in the or when you make your own notes, use the notes that I posted in Canvas and just write these down. But we can write them from here too, or in your homework. But yeah, that's pretty much it. End behavior. And you can always check work by graphing. All right, let's move on to something else. Okay, let's look at the last question in this section. I think this is a good one just because it kind of brings it all together. So, if you were to do the work, you should see that if the zero for this term is 3, right? Plug in a 3, get a 0 with multiplicity 3. And this has a 0, 1 with multiplicity 1. So there's something I didn't mention before is odd multiplicities are going to go through the graph. So like this goes through wherever there's a 0, if it goes through, then that means, sorry, it goes through the x-axis. That's what I meant. That means that your 0 is odd. Now, if it bounces off the 0, bounces off, then it's an even multiplicity. So that's one way you can kind of choose your correct graph. So the first thing is, what is the degree of f? We got a 3 and a 1, has to be 4. So it has to be even. So for f, it has to be either C, the ones that have parabolic shape. So if it's even type, then it should have a parabolic shape. C, E, F. It has to be one of those. Okay. Now, it's going to be, if you were to multiply all these first terms together, the x cubed, and 4, like we were talking about that last example, then it would be positive. So it has to be opening up and parabolic shape. So it has to be C or F. So now we're down to two answers. Okay. So again, we're not using a graphing calculator. We're just trying to figure it out using all the information. Now, of course, you could use your calculator and just pick the correct answer or Desmos, but if you do it without the calculator, then you're gonna use all the information from this section. So that's the only reason I want you to do it that way, just so you can understand the ideas. So it's opening up has to be C or F is what we said. Now the zeros, 3 right there, and 1 are right here, so it can't be, hold on a second. So you can tell right away that it has to be graph F for F. F has to be graph F because it has a 0 at 1 and 3 right there. So the only one that has the correct zeros is F. So once we rolled everything out, the only one that made sense was F. Now this is an odd. G is odd, so it has to be A, B, or D. And it has to be flipped. So it has to be, the graph has to be B or D right here. So now the only way to rule it out is which one has the correct intercepts. So you'd have to factor this and solve it. Um, Let me show you this, the explanation here. They have it factored for us. Okay, where is it? D. Here's the factorization. So they take an x out of each term, and you get to here, a negative x. Then they factor this part using your basic trial and error. So now we have 3 factors and 3 zeros. So it has to be the one that goes through 0, goes through 2, goes through -4 right there. So that's how you roll out everything else. So use your end behavior, use your zeros, and your multiplicity rules. So remember, even multiplicity bounces off zeros, odd crosses it, and even functions have to be pointing go in the same direction on both sides, like this one here, like C and these two, pointing up or pointing down. But that's pretty much it. All right, let's go to another section.